All right, guys. What we want to do is tonight is we want to take those two special right triangles that we talked about for the past week or so, and we want to put those inside of a coordinate plane. So I'm going to get some graph paper here, and you can do the same thing in OneNote. You can get yourself some graph paper and then title it Special Triangles in a Coordinate Plane, just like mine is. So before we throw these triangles in here, there's a couple of definitions that I need to give you regarding the coordinate plane and some reminders about that. Let me see if I can drag myself a decent sized coordinate plane here and center it relatively well. A little lag on my computer. Okay, good enough. So as you know, just kind of a couple real quick reminders. Here's your x-axis, and here's your y-axis. And I know that you're used to seeing this coordinate plane just as an x-axis and a y-axis, but we're going to start thinking of it in terms of putting angles on this thing and putting triangles on here. So you need to kind of expand your thoughts about this picture here. That's still the origin. That's still 0, 0. That's all good. But this x-axis, we're going to give this a new name. It is still the x-axis. It will always be the x-axis, but we're also going to call it the initial side. And we're going to create angles from this initial side as if this blue ray that I'm kind of tracing here is one side of your angle. And you need to kind of picture it as if the two rays of your angle are both on top of that blue ray, and then you're lifting one of those rays and moving it off of there to make your angle. So now your angle sort of has direction, if you will. You can think of it as like all angles start at 0 degrees on the initial side where both of the rays are sitting on the initial side. And then you're picking up one of the rays of the angle and you're lifting it up off that initial side until you create your angle. And then that second ray that you've created then is called the terminal side. So you can draw angles that start on your initial side. I'll draw one in red here. And now I'm sort of pretending that my entire angle is just 0 degrees, that red angle is 0 degrees, both rays sitting on the initial side. And then I'm going to lift it up, lift one of those rays up and move it all the way over here. So now I have that red obtuse angle. And now the initial side is still here. The initial side never moves. And now my terminal side is here. So I've just drawn two different angles on this coordinate plane. One of them is blue. I don't know, I can probably estimate that blue angle is like maybe 40 degrees. And then one of them is red, and I'm going to estimate that red angle is maybe like, I don't know, maybe like 120 degrees, something like that. So now you've got initial sides and you have terminal sides of your angle. The initial side is always right on top of the positive x-axis, and the terminal side is wherever your angle ends up. Okay, so having said that, there are four sort of like important angles on this. Oh, wow, horrid. Sorry, my rays are like a mess. On this angle. Let me see if I can clean that up. That's going to bother me. Yeah, it's a little bit better. Okay, so one of those angles is this one. Starts on the initial side and measures to here, my terminal side. And that one is a 90-degree angle. One of them starts on the initial side and measures all the way over here. And that's your 180-degree angle. Okay, but now we're going to start talking about angles that are bigger than 180 degrees. We're going to start in green on the initial side, and we're going to go all the way over here to the terminal side, and that is 270 degrees. 270. And then the last one, I'm running out of colors, so we'll go gray. Starting at the initial side and going all the way around clear to here. And that's 360 degrees. And that looks exactly like 0 degrees because the initial side and the terminal side are sitting right on top of each other, just like a 0 degree angle. So those are kind of like 4 really important angles that we need to kind of keep in mind as we start to throw some triangles on this coordinate plane. Okay, now let's draw some triangles. Okay, so here's my initial side, starting at 0, 0 and going to the positive x-axis. And I'm going to go up to about right there. And I'm going to call that a 45-degree angle. And I'm going to say that the length of the hypotenuse is, that the length of that segment right there is, let's say, I don't know, 5. What I want to know are the coordinates of that point right there. That's my goal, is to figure out the coordinates of that point right there. So what I'm going to do is I'm going to use what I already know. And what you already know is because you've got a 45-degree angle here, you know that you can use a 45, 45, 90 triangle. So I'm going to drop a leg and create a 45, 90 triangle. And now, because this is 45, 90, I'm not even thinking about this point right here, you know, the stuff that I'm looking for. I'm not even thinking about that. I'm just strictly thinking about the triangle right now. And so now, because this is 45, 90, I've got a hypotenuse that's 5. And you know that the leg to hypotenuse ratio is 1 to rad 2. So to get that leg, I need to divide by radical 2. So I'm going to go 5 divided by rad 2. Red flag, you know, you can't have a radical in the denominator. So let's rationalize that. And now I know that this is the length of that leg right there. Well, because it's a 45, 90, that means this triangle is isosceles, which means this is the length of my other leg as well. Okay, now let's go back to the original question. The question was, what are the coordinates of this point right here? So if you think about what it takes to plot a point, when you plot a point, you always start at 0, 0, and you head over to the right and then up. And so, because I have found the legs of this triangle, I know that my over to the right is 5 rad 2 over 2, and I have to travel up 5 rad 2 over 2, and so those are the coordinates of that point. So all we're doing is we're just taking our knowledge of the special triangles, in this case the 45, 90, and we're putting it onto a coordinate grid and finding the coordinates of points using those special triangles. Now in the first quad, it's a pretty piece of cake, but let's look at one that might occur in like the second quad, for instance. I'm going to start on my terminal side, my initial side, and I'm going to draw an angle that stops about right there. And I'm going to say that that angle that I just drew is 135 degrees. Okay, and I know that this length right here, I'm just going to randomly pick a number. I'll say it's 8, just because I feel like it. Nothing special about it. And again, I want to know the coordinates of that point right there. Okay, well, let's drop a leg, make this a right triangle, and try to see if there's anything special about that right triangle. So I'm just going to drop a leg, make a right triangle, and then I'm going to just try to see, like, is this a special right triangle or is it just a Joe Schmo right triangle? I'm really hoping that it's special because that way I can, you know, use my skills, my 30, 60, 90 or 45, 90 skills to try to figure out the coordinates of that point up there. So, well, here's the deal. Like, I know that this entire and I also know that the blue distance that gave me the blue angle is 135 degrees. So if I subtract those two, I find out that this angle right here is a 45-degree angle. And well, that's great news because now I know that's a 45, 45, 90 triangle. So I can use my information about that. That means this leg is 8 divided by rad 2. Rationalize that. 8 rad 2 over 2. Simplify that, and I get 4 rad 2. Again, because it's isosceles, that means my other leg is also 4 rad 2. Okay, so now I've got the information I need to be able to figure out the coordinates of this point here. So here's the deal though. Direction absolutely means something. Direction matters. To plot this point, I'm going to start at 0, 0, and I'm going to go to the left 4 rad 2, which means it's negative 4 rad 2. And then I'm going to go up 4 rad 2, which makes that a positive 4 rad 2 for my y. You do need to pay attention to direction. Direction really does matter. Okay, let's see if we can squeeze one more in here real quick. And this time, let's draw an angle that is 150 degrees. Okay, drop my triangle. That gives me this reference angle. That's what these angles are called inside the triangle. It gives me a reference angle of 30 degrees, which means this is a 30, 60, 90. So now, if I was given that the hypotenuse is, again, I'm just going to make up a number, we'll say 10, and I want the coordinates of this point here. Well, this is a 30, 60, 90, so I know that the hypotenuse to short leg ratio is 2 to 1 or 1 to 2. That makes my short leg 5, and it makes my long leg 5 rad 3. But keep in mind, the direction is important. I have to go to the left minus 5 rad 3, and then up 5 units. So the coordinates of my point are negative 5 rad 3, 5. Okay, we're going to do a lot more problems like this in class, and we're going to get them out of the second quad and go like some triangles in the third quad and some triangles in the fourth quad. We're just going to really see like what's it look like when you have these special triangles in a coordinate plane. But this should help at least kind of get you started thinking about it. All right, we'll see you in class.